Hi and welcome. Today we're going to go through 3 different problems on proving trigonometric identities. First things first, we have the 2021 O-Level A Math Paper 1 question right here, which is to prove this identity right here, that sine of theta over 1 minus cosine of theta minus 1 over sine of theta is equals to cotangent of theta. First things first, let's figure out which side to work from, the left-hand side or the right-hand side. Well, the left-hand side is a lot more complicated, so let's work from there towards the more simpler right-hand side. So that's going to be the left-hand side is going to be sine of theta over 1 minus cosine theta minus 1 over sine theta. Okay, so we probably want to combine these two fractions together because the right-hand side only has one term, which is cotangent of theta. Well, we see that in the denominator right here, we have 1 minus cosine of theta. We know that a squared minus b squared is equals to a plus b, a minus b. So we have 1 minus cosine theta, which is a minus b. Why not let's multiply the numerator and denominator of the fraction by 1 plus cosine of theta. So this is going to be sine of theta times 1 plus cosine of theta all over 1 minus cosine of theta, then 1 plus cosine of theta subtracted by 1 over sine theta. Okay, now let's try to distribute over here. So this will give us sine of theta plus sine theta cosine theta over, this is going to be 1 squared, which is 1, minus cosine square of theta minus 1 over sine theta. Okay, now what should we do? Well, the denominator is 1 minus cosine square of theta. We know that sine square of theta plus the cosine square of theta is equal to 1. So let's subtract cosine square of theta on both sides. This will give us sine square of theta is equals to 1 minus cosine square of theta. So the denominator right here is actually sine square of theta. So let's rewrite it like that. It's going to be the sine of theta plus sine theta cosine theta divided by sine square theta minus 1 over sine theta. Let's now try to rewrite the fraction such that we can combine the two fractions. To do that, we need a common denominator. Well, here is the sine square of theta, and here is the sine of theta. So why not let's multiply the numerator and denominator of the second fraction by sine of theta. This is equals to the sine of theta plus sine theta cosine theta over sine square of theta minus sine theta over sine square of theta. So we can combine these two fractions now because they have the same denominator, sine square theta. So it's going to be sine theta plus sine theta cosine theta minus sine theta. Alright, we have a sine theta and minus sine theta, so those two things cancel out. So we can rewrite in the expression in the form of sine theta cosine theta over sine square theta. There's a sine theta on the numerator and denominator, so let's go ahead and cancel that out. This gives us cosine of theta over sine theta, which gives us cotangent of theta, which is the right-hand side. So that is proven. Alright, let's move on. Next problem, we are going to be proving this identity from the 2022 O-Level A Math Paper 2. We are going to prove that tangent of 2 theta times 2 cosine theta minus secant theta is equal to 2 sine theta. So, first things first, let's figure out which side to work from. Well, the left-hand side is a lot more complicated, so let's start from there. So the left-hand side is going to be equals to tangent 2 theta times 2 cosine of theta minus secant of theta. Alright, we see that we have a tangent of 2 theta. It reminds us of the double angle formula. So maybe let's just use it at double angle formula, but hang on. If we were to rewrite this, it would be equal to what value? Well, just loading up my formula sheet real quick. This is going to be equals to 2 tangent theta over 1 minus tangent squared theta. I mean, that's good and all, but like the right hand side for this equation is in the form of sine of theta. But here there's still a bunch of tangents, so maybe we should try to change the tangent into something else instead of using this double angle formula directly. Well, recall that if we have the tangent of 2 theta, this is going to be the sine of 2 theta over the cosine of 2 theta. So let's rewrite it as such. This is going to be the sine of 2 theta over cosine of 2 theta times 2 cosine theta minus secant theta. Alright, now we can probably use a double angle formula for the sine of 2 theta and the cosine of 2 theta. For the sine of 2 theta, it's pretty straightforward. It's just 2 sine theta cosine theta. But the denominator, there's 3 ways to break it down. So let's just leave it as cosine 2 theta for now. So this is going to be 2 sine theta cosine theta 2 cosine theta minus secant theta all over cosine 2 theta. Now let's distribute over here. So we get 2 times 2, so that's 4 sine theta. We have cosine theta times cosine theta, so it's cosine square of theta. Now we have cosine of theta and secant of theta being multiplied together. Recall that secant of theta is equal to 1 over cosine of theta. So if we have the cosine of theta times the secant of theta, which is 1 over cosine of theta, this would be equal to 1. So it kind of cancels out. So we are just going to have minus 2 sine theta all over cosine 2 theta. Okay. From here, it seems like it's still a bit complicated. We can probably simplify our fraction a little bit more before we try to continue. So let's factorize it. We can see that from the numerator there's a common factor of 2 sine theta. So it's going to be 2 cosine square of theta minus 1. Well, the denominator of cosine 2 theta just so happens to be able to be broken down into 2 cosine square of theta minus 1. Which means that these two cancel out, leaving us with 2 sine theta, which is the right hand side. So that's proven. Alright, last part. We are going to be proving that the cosine square of theta over cosecant theta minus 1, cosecant theta plus 1, plus sine square of theta over secant theta minus 1, secant theta plus 1 is all equal to 1. This is from 2023 O-Level A Math Paper 1. Alright. We see that at the bottom. We first see that the left-hand side is a lot more complicated, so let's start with that. Left-hand side is going to be equals to cosine square of theta over cosecant theta minus 1 cosecant secant theta plus 1 plus sine square of theta over secant theta minus 1 secant theta plus 1. Okay, so we see that the denominator is in the form cosecant theta minus 1 cosecant theta plus 1 a minus b a plus b. So let's do that. And let's go ahead and re-express it. So it's going to be cosine square of theta over cosecant square of theta minus 1. Similarly, we have sine square of theta, secant theta minus 1, secant theta plus 1, so it's going to be secant square theta minus 1. And yeah. Alright, now what do we do? Well, based on our formula sheet, we have secant square theta is equals to 1 plus tangent square of theta. If we subtract 1 on both sides, we get tangent square of theta is equal to secant square of theta minus 1, which is this thing right here. So this is just tangent square of theta. Now, on the other side, we have this right here. So this, from the formula of this, we can find that cosecant square theta is equals to 1 plus cotangent square theta. Again, subtracting 1 on both sides, we get cotangent square of theta is equals to cosecant square theta minus 1. So the denominator in this case is just going to be cotangent square theta. Alright, let's go ahead and re-express all this. Cosecant square theta over cotangent square theta plus sine square theta over tangent square theta. Alright, let's go ahead and maybe re-express tangent as sine over cosine, and cotangent as cosine over sine, and let's see what happens. So this is going to be cosine square of theta over cosine square theta over sine square theta. It's squared because we have cotangent squared, plus sine square theta over, this is going to be sine square theta over cosine square theta. So for this fraction, we are going to be multiplying the numerator and denominator by cosine square theta. For this, we are going to times sine square theta. So this is equals to cosine square theta sine square theta over cosine square theta plus sine square theta cosine square theta over sine square theta. Well, the numerator and denominator for the first fraction both have cosine square of theta. Numerator and denominator for the second fraction both have sine square of theta. So we end up with sine square of theta plus the cosine square of theta, which, using the formula of this, gives you 1. So this is the right hand side, and therefore it is proven. Thank you so much for watching, and I'll see you guys next time.